Artificial intelligence, AI, is a field of computer science that aims to develop intelligent machines capable of performing tasks that typically require human intelligence. This article provides a thorough and elaborate examination of artificial intelligence, covering its history, key concepts, subfields, applications, challenges, and future prospects. Introduction to Artificial Intelligence, AI. Artificial intelligence is a branch of computer science that focuses on creating intelligent machines that can mimic human cognitive functions. These machines can analyze data, learn from it, make decisions, and solve problems autonomously. AI aims to replicate human intelligence or even surpass it in certain domains. History of artificial intelligence. The concept of AI dates back to ancient times, with myths of artificial beings and automatons. In the 20th century, early AI pioneers like Alan Turing and John McCarthy laid the groundwork for AI research. The Dartmouth Conference in 1956 is considered the birth of AI as a field of study. However, progress faced challenges during periods known as AI winters, when funding and interest in AI research declined. The recent advancements in computational power, big data, and algorithms have led to the AI boom in the 21st century. Key concepts in AI. Machine learning, ML. A subset of AI, ML enables machines to learn from data without being explicitly programmed. It includes supervised, unsupervised, and reinforcement learning. B. Deep learning, DL. A subfield of ML that employs artificial neural networks to process and learn from large amounts of data. Deep learning has revolutionized various AI applications, including image and speech recognition. C. Natural language processing, NLP. NLP enables computers to understand, interpret, and generate human language. It underpins chatbots, virtual assistants, and language translation systems. D. Robotics and automation. AI-powered robots and automation systems can perform tasks in manufacturing, logistics, and healthcare, among others. E. Expert systems. These are AI systems designed to replicate human expertise in specific domains, making them valuable for decision support and problem solving. 1. Types of AI. A. Narrow AI, weak AI. AI systems designed for specific tasks or domains, like playing chess or driving a car. B. General AI. Strong AI. AI with human-level intelligence, capable of understanding, learning, and performing any intellectual task that a human can. C. Reactive machines. AI systems that don't possess memory and operate based on predefined rules, suitable for specific applications but incapable of learning. D. Limited memory AI. AI systems that have some memory capacity and can learn from historical data to improve performance. E. Theory of mind AI. A hypothetical AI concept that could understand human emotions, beliefs, and intentions, leading to more empathetic interactions. 1. Machine learning and deep learning. A. Supervised learning. The ML model learns from labeled data, making predictions based on previous examples. B. Unsupervised learning. The ML model learns from unlabeled data, finding patterns and relationships within the data. C. Reinforcement learning. The ML model learns through trial and error by receiving feedback in the form of rewards or penalties. D. Neural networks. Artificial neural networks mimic the structure and function of the human brain, with interconnected layers of neurons. E. Training and optimization. ML models undergo training processes to optimize their performance using techniques like gradient descent. F. Transfer learning. It involves leveraging knowledge from one task or domain to improve performance in another. 1. Natural language processing, NLP, and AI in language understanding. A. Speech recognition. NLP systems can convert spoken language into text, enabling voice-controlled applications. B. Text understanding and generation. AI can understand and generate human-like text, useful for chatbots and language translation. C. Sentiment analysis. NLP can determine the sentiment or emotion expressed in a piece of text, valuable for market research and social media analysis. D. Language translation. AI-powered language translation systems can bridge language barriers and enable effective communication across cultures. 1. Robotics and automation. A. Robotics in manufacturing and industrial applications. AI-powered robots can perform repetitive tasks with high precision and efficiency, enhancing manufacturing processes. B. Autonomous vehicles. Self-driving cars and drones use AI to navigate and make real-time decisions on the road or in the air. C. Social robots and human-robot interaction. Social robots equipped with AI capabilities can interact with humans, providing companionship or assistance in various scenarios. 1. Expert systems and knowledge representation. A. Rule-based systems. Expert systems use a set of predefined rules to make decisions and offer expert-level advice. B. Inference engines. These components of expert systems draw conclusions based on provided rules and data. C. Ontologies and semantic web. AI systems use ontologies to represent and organize knowledge in a structured manner, facilitating data integration and semantic understanding. 1. AI in various industries. A. Healthcare and medical diagnosis. AI aids in medical image analysis, drug discovery, and disease diagnosis, potentially improving patient outcomes. B. Finance and algorithmic trading. AI algorithms analyze financial data, helping with trading decisions and risk management. C. Transportation and logistics. AI optimizes route planning, fleet management, and logistics operations. D. Entertainment and gaming. AI-powered characters and game opponents can offer challenging and immersive experiences. E. Customer service and chatbots. AI-driven chatbots handle customer inquiries and support, providing efficient and round-the-clock assistance. 1. Ethical and societal considerations. A. Bias and fairness in AI. AI models can inherit biases present in training data, leading to unfair or discriminatory outcomes. B. Privacy and data security. AI systems often deal with sensitive data, necessitating robust privacy protection and data security measures. C. Job displacement and the future of work. The automation of certain jobs may lead to job displacement, necessitating reskilling and workforce adaptability. D. Regulation and governance of AI. As AI becomes more pervasive, the need for responsible regulation and ethical guidelines becomes essential. 1. Challenges and limitations. A. Data availability and quality. AI models require vast amounts of high-quality data for effective training and performance. B. Interpretability and explainability. AI models can be complex and challenging to interpret, raising concerns about transparency and accountability. C. Overfitting and generalization. AI models may perform well on training data but struggle to generalize to unseen data, leading to overfitting. D. AI safety and robustness. Ensuring that AI systems behave safely and robustly in real-world scenarios is a critical challenge. 1. Future prospects of AI. A. AGI and superintelligence. The pursuit of artificial general intelligence, AGI, aims to create machines with human-like intelligence. 1. Superintelligence, if achieved, would surpass human intelligence significantly. B. AI's role in solving global challenges. AI has the potential to contribute to solving significant global issues, such as climate change, healthcare, and poverty. C. Collaborative intelligence. The collaboration between humans and AI, known as collaborative intelligence, could lead to transformative advancements in various fields. 1. Conclusion. Artificial intelligence continues to evolve, impacting various aspects of society and technology. 1. Its potential to enhance efficiency, solve complex problems, and transform industries is substantial. 1. However, addressing ethical concerns, ensuring responsible development, and fostering collaboration between humans and AI are vital for harnessing AI's benefits while mitigating potential risks. 1. Continued research and innovation will shape the future of AI, leading to exciting possibilities and challenges that lie ahead.